Calthamites or straw stalactites? Today I'm going to tell you a young Earth creationist apples versus oranges story. It involves the origin of cave formations, and specifically stalactites, which are the delicate formations hanging from the top of a cave. Young Earth creationists who believe that the world was reshaped less than 4,500 years ago by a cataclysmic worldwide flood don't believe that any cave formation that we see on Earth is any older than 4,500 years. And therefore, all of these ornate structures inside of caves must be younger than 4,500 years old. Now, anyone that's visited a cave, taken a tour, will have heard the description of stalactite and stalagmite formation and how they're precipitates of calcium carbonate, usually in this particular case, in a limestone cave. And how that takes a long time, how the very gradual dripping and production of stalactite material only builds up on the order of maybe a millimeter or two a year on average. And therefore, large structures like this are tens of thousands, if not hundreds of thousands of years old. That certainly doesn't fit into that 4,500 year range the young Earth creationists need to fit it in. So young Earth creationists find caves to be a serious challenge. They admit that if you measure the rate of stalactite formation in many caves around the world, that the actual observed rate of new stalactite formation is very slow and would, if you extrapolate back, result in caves that are tens of thousands and hundreds of thousands of years old. So how are they going to get around this? Well, the number one thing to do is say, were you there, right? Were you there in the past to see those stalactites form? Maybe they form more quickly in the past than they do the present. Now, that seems like a stretch, and so it helps to have actual, modern day examples of maybe fast stalactite formation, which would then maybe be used as, even though they're exceptions, to suggest that maybe that was the rule in the past. And that's exactly what they have done. So here on creation.com from Creation Ministries International, we have a very recent article, Stalactites in a Pub Cellar, showing how cave structures don't always form by slow and gradual processes. And this is a picture of the cellar of a 200-plus-year-old pub in England. And these thin little straws you see are called soda straws or straw stalactites, and they have formed from the ceiling of this cellar. And since this cellar is less than 300 years old, these 12-foot long soda straws must have formed within the last 300 years. I don't know anyone who would disagree with that. It's very sound logic. But the point, of course, is that if they form that quickly, the rate of growth of those soda straws is very, very fast compared to the measured rate of growth of stalactites in natural caves. So this quote pretty much sums it up. The slow growth rates currently observed from many stalactites cannot be extracted uniformly backward in time to calculate a date. So there's your plausible denial, right? Since there are examples where they grow quickly, we can't trust that when you haven't been there to see it in the past, that maybe in these caves the conditions were different in the past, like maybe right after the flood, and therefore the stalactites might have grown much, much quicker than they do today. So this article by Gavin Cox explains his trip and his pictures he took at this particular pub, and talks about this relationship of fast-growing stalactites to the past stalactites in other caves, maybe growing much quicker. And then he talks about how we need to use this critical thinking and we need to not just listen to these stories of millions of years, because it isn't necessarily millions of years. Now, I wouldn't consider this to be a strong argument for the world being young. It's simply how can we get out of this problem where it looks pretty obvious that the world isn't young? We got to have some kind of excuse, something to grab onto, and this is the thing they're clinging on to. So now my title said an apples and oranges story, and I think you can probably see where I'm going to go. And I'm going to ask the question, are these soda straws or these straw stalactites growing in this pub cellar equivalent to the stalactite growth found in natural caves? And my answer is going to be, I don't think so. And so the cave cellar doesn't really help out very much in relieving the stress of the problem of old caves. All right, that's giving away the end of the story, but how do I get there? All we need to do is look at, it didn't take me more than a few minutes of research to find out there's one big piece of the story missing in Gavin Cox's article and several other articles on the internet by creationists at creationist websites that also use this particular example. They don't really ask the pertinent and more difficult questions about the soda straws themselves. There's no analysis of them. It's simply observational, right? It's simply gross anatomy, I'll say, of the stalactites. Hey, I took this picture. This is what they look like. They look like stalactites, and therefore they are stalactites, and they grew fast, and therefore those other ones could have grown fast too. That's not using critical thinking. I'll say that because there's a lot of ways we can test these two objects to see if they're an apples to apples to comparison or an apples to oranges comparison. Let's just use this short article by Gary Smith comparing calthamites to speleothems, straw stalactites. And what he does in this article is he looks at these two different types of formations that look very similar and asks, are they in fact the same thing? So I think we can get right down to it with just two paragraphs. Beneath concrete structures, calcium carbonate is precipitated from hyperalkaline solution to create calthamite deposits which mimic cave speleothems. I can never say that term. Under ideal conditions, calthamite straws can grow in length hundreds of times faster than speleotherm straws due to their greater calcium ion carrying capacity of the hyperalkaline leachate solution and different chemistry involved. All right, now what he's saying here, did you notice beneath concrete structures, you have this hyperalkaline solution which allows for the dissolution of calcium ions at a much faster pace and therefore a much greater concentration in the solution that's dripping. That's going to allow the straws to form at a very, very fast pace compared to their natural, typical cave formation. Ford and Williams state that the rates of growth are usually quoted in terms of the extension of a given form rather than the accumulation of mass. We'll get to that in just a second. Straw stalactites grow fastest because they have the greatest extension per unit of area deposited. Growth rates between 0.2 and 0.2 millimeters per year are quoted for speleothem straws, all right, 0.2 to 2 millimeters per year. And you imagine that some of these stalactites you see in these caves or these soda straws that are 20, 30 feet long, if you back calculate that and they're only growing at 2 millimeters per year, well, then you're getting into thousands of years to produce them. Whereas a calthamite straw can grow up to rates of 2 millimeters per day. They're very quick to produce. And I'll just note that when I walk out of my building here in a little while, I'm going to see on the overpass, which is a cement overpass between two buildings, I see a number of calthamites hanging down there, and I've observed them growing in the past couple years. But just because they look like a stalactite doesn't mean they're the equivalent of a stalactite in a cave. They're not. It's not an apples to comparison because of how they grow. Well, is there more to this particular story? All right, so here's a couple pictures. And again, pictures don't really tell the story. You can look at something visually and say, they look kind of the same. A calthamite versus a speleothem straw. This picture is worth a lot of words, right? Here's a calthamite, and what he did was he went out and collected these soda straws that are forming underneath concrete in concrete basements and under overpasses and other places where concrete formations are. And then he took ones from natural caves that are forming from limestone blocks, dripping from limestone blocks. And you'll see there's a difference here. You see how thin the walls are on these calthamite straws versus how thick they are over here. That alone should inform you that it takes a lot longer to form a speleotherm straw versus this other one. He's got a number of interesting graphics. I'm not going to show you those, but In the graphics, he actually compares the relative thickness, so it's the total mass being produced. So one particular straw these are 4 to 8 times as much mass in a particular straw. So if you're just measuring the length of them and thinking about the amount of time it takes to produce the length, it's going to take a lot more time, even if you're precipitating at the same rate. But these particular soda straws are precipitating, we already know, at much higher rates, just understanding the chemistry and the amount of calcium ion that's going to be precipitated from cement. And so they're going to produce much, much more quickly. And when you add up the total mass, there's not even nearly as much mass there in these straws. So in that particular straw, and the other thing I noticed then was, going back to the pub, is it noted that those were limestone blocks that it was dripping from. So that kind of makes it sound like, in the articles that I've read from Creationists, that, this is like a limestone cave, and so they are precipitating from these limestone blocks. But what they don't show, and what I can see there, is that the limestone blocks are, they're not in a natural formation. They're limestone blocks that were brought in to make that particular cellar. They're probably held together by some kind of mortar, and then on top of that, you have the building that has a cement foundation. And so the cement is leaching out chemicals into the limestone, and in fact, the cement is probably causing the limestone below it to be eroded more quickly, allowing for a much faster pace of these production of these what's called calthamite. The calthamite also has a slightly different chemical composition as well. So if they had done further studies, what young Earth creationists need to do, is they need to go in and actually analyze the structure of these particular straws and ask themselves about, for one thing, figure out the total mass, so they can actually do a calculation of the relative difference of the amount of total material being deposited over time. So just because they grew 12 feet in 200 years, the amount of mass that was put down is far less than you find in, say, in the soda straws in a cave, which are much more dense. And so even the ones in the caves are going to take thousands of years, to grow to that same length, even if they're growing as fast, just because they had that much more, well, maybe not thousands of years, but hundreds of years, right? Thousands of years, because these are 200 years old. If you take 4 to 8 times as much mass, you're looking at a couple thousand years just for simple soda straws. Okay, the other thing that is lacking in the Young Earth Creationist article about these stalactites is that they're not only comparing something that is produced in a different way and under different conditions, so these calthamites are produced under different conditions than most cave soda straws or stalactites. But they're also doing an apples and oranges comparison when they talk about the rates, in the sense that they're comparing the rates that are published for stalactites, but not stalactite straws, but like the large stalactites that you see that are formed in a different way than the straws do. Stalactite straws are considered to be very fast growing compared to your other stalactites and stalagmites. Stalactite straws are fast growing relative to others. And so a stalactite straw can grow under natural conditions in natural caves fairly quickly. So a 12-inch straw might only be, might be 50 or 100 years old. They're not thousands of years old. And so it's not actually even a correct comparison to say, like, here's these straws and they're growing very quickly. Now look at these massive stalactites in these caves. Well, they could have also formed that quickly. When you think about the total amount of mass of calcium carbonate that has to be precipitated, it's not anywhere near the same comparison if you're comparing two straws to one another. But so that overgeneralization that they make also creates this contrast and makes it sound simpler to create these fast stalactites. So it's once again, we find that creationists are in a bind. They have a difficult problem, and in order to escape that problem, they need to find modern analogs that at least give a hint or a suggestion that these objects could form more quickly than they appear to. But even the examples they're going to are not an apples to comparison because they're not chemically the same. They're not produced under the same conditions. And if you even do more research, and there's that paper is actually interesting because there's even more details there. There are ways to do cross sections of soda straws. And in the cross section, you can look at the buildup of other precipitates in addition to calcium carbonate. And you can determine the rate of speed in which that particular straw was probably formed at different time periods when it slowed down and sped up. And that's based on different types of chemistry. And so when young earth creationists will claim, oh, well, were you there? You weren't there in the past, so how do you know how fast it grew? Well, actually, there are ways. If you wanted to know, you could tell at least relatively when things grew faster and when they were growing the same rate. Something that is precipitating at a particular rate will leave patterns of basically types of rings and structures that are identifiable as to the rates at which they were acting. And so by taking a cross-section of an old stalactite, you can tell something about its rate of production at that particular time. And so simply keeping it general and just saying, oh, well, it just could have grown faster in past. Well, that's not doing the hard work of actually looking at the evidence and asking the question, maybe there's evidence that it didn't grow fast in the past. You should make a hypothesis and maybe make an observation and test that prediction rather than simply showing pictures of two things that look similar and saying, this one grew fast, this one they claim didn't grow fast, and therefore that one could have grown fast. Because that's what the whole argument basically boils down to for young earth creationists. But start to do some critical thinking, apply a little bit of science to the question, and you find that these arguments fall apart and they're not left with really any kind of solution to their cave problem at this point. So we'll wait and see if something else, if they come up with another explanation. Unfortunately, I don't think they do have to come up with another explanation because most of their audience is perfectly willing to accept this particular explanation. And so there's no need to kind of continue. And sadly, actually investigating these particular soda straws in the basement of this cellar would not lead to any better outcome. And so it's better to just leave it simple and leave it at the eyeball test rather than try to collect actual data, which might undermine your own hypothesis. But I would encourage them to do that. Test those hypotheses, because if what you believe to be true is true, then you may find out that this isn't a good explanation, but it wouldn't necessarily mean you have to give up on your ultimate goal. You just need to look for evidence elsewhere. But at the end of the day, pretty soon, once you can't find any evidence, maybe that's a chance to rethink your original hypothesis. And that's how science works. Testing those hypotheses and coming back and asking, well, where did I go wrong? Hey, I'm Joel Duff, and thanks for listening. That's the story of calthamites versus straw stalactites. It really is an apples to oranges story. Thanks a lot.